In this episode, Rick will talk through common issues with the 4.0, overheating, blown head gaskets, broken timing chains, and what oil to run. We'll discuss casting issues like slag and core shift, and finally, how to rub a casting for performance.
We got a whole section here on common complaints of the 4-liter. So the first and the biggest is, why is it so hard to keep cool? Everybody has these overheating problems with their 4-liter, and it's known for having heating problems at the end of the block. So
blown head gaskets?
Yep.
I can tell you how to fix that.
Well, let's hear it. What's the problem and how do you fix it?
Well, you know where the freeze plugs are on the side of the block?
Yep.
I did this on the Jeep race engine, on that Hill & Williams 4-liter drag car for NHRA. I made up some little aluminum pucks that went into where the freeze plug would normally be. The freeze plug is actually a misnomer because it's actually a clean-out hole.
It's a core plug, yeah.
Yeah, so they just go in there and clean out the sand and stuff with those holes when they cast the blocks. But anyway, I made up some pucks. They're aluminum, and they had a drilled and tapped hole in the middle.
Yep.
And then once I put an O-ring in it, and I plugged it in there, and it wasn't a line-on-line fit. It was snug. It went in there snug, and then you could put a couple of pan head screws on either side of it to hold it in. You just drill and tap on each side and hold it in there.
Yeah.
And then I put an AN fitting that was like a 60-degree AN fitting that shot water straight up at the bottom of the deck and shot to shoot water between the cylinders. The biggest problem is that the water stagnates between the cylinder bores.
Mm-hmm.
So like at the front of the block where the water pump is, no problem. At the back of the block where the water goes by number 6, no problem. But you start going down. We ran temperature gradients across this with thermocouples. This engine was completely filled with thermocouples. They were everywhere. There must have been 250 thermocouples in this engine.
Wow.
It was all over the place. And we had, thermocouples going up the bore and in between the bores going up the bore. And we had, from front to back, we had a complete map of temperature gradients. And we noticed that all the temperature, like right at the deck, was pretty hot, even toward the front, like between 1 and 2 and 2 and 3 and 3 and 4 and 4 and 5. And as you progressively went from 1 to 2 to 3 to 4, it got hotter and hotter and hotter and hotter. So you got to between 5 and 6, it was boiling. It wasn't just hot water. It was making steam in there.
You were making steam off the back 2 cylinders.
Yep. I came up with this little fix I told Garth, I said, even though this is a short duration engine, I said, you'll never be able to run a stock head gasket on there. I said, it won't work. He says, why? And I said, because it'll blow number 5, between 5 and 6. It'll blow every time.
Yep.
And they said, well, how do you know that? And I said, because I've been around the testing. I know what it's doing. I said, the cylinder head's part of my job, but it's also the cooling system is part of the cylinder head. So he says, well, what are we going to do? So that's when I came up with the puck thing, and I said, here, just put them in here and get these AN fittings that aren't 60 degree. And I said, by looking at the print, the 60 degree will shoot her right up and the 2 bores start to come together. I said, you'll get enough turbulence going through there, it'll keep it cool.
I didn't put pucks in, but the 2 drain plugs at the bottom of the block, you have one that sits between 3 and 4, and the other one sits in between, just ahead of number 5. Plugged a pressurized pump in there as well, and when you hit it with the pressure, it really cools down some cool cylinders.
Yeah, it works.
I totally get it. Looking at the design of the cooling system, you're pumping water from the front to the back. You got the big hole at the back, but everything in the middle.
All it does when the water's going by, it's just spinning in there. It's like a little toilet bowl just turning and turning and turning. It doesn't cool very well at all.
Well, That makes total sense. Well, that was a big question for folks as well. How to keep it cool and what to do to make it cooling better.
You know, if you put a couple of lines, drill and tap the side of the block down just a touch below the in the water jacket, and then you could put like a little nozzle deal, shoot that water right through that area. It's under the top of the deck. Just shoot water right through that area on like between 4 and 5 and 5 and 6. 5 and 6 is the worst. 4 and 5 is pretty hot too.
Yeah, that makes total sense.
And then the rest of them, you know, you can get by.
That leads into the next question, which people were really curious. What's the most common thing that failed in the longevity or destruction testing?
Okay, durability. You know, I worked in engineering, and engineering is a funny place because they try a lot of stuff.
Mm-hmm.
So, you know, like they'll try water pumps and they fail, and then they finally come up with a pump that works. But a lot of times they'll end up going back to something that worked in the past, but it may not be made out of iron, it may be made out of aluminum, just to save weight, you know, for fuel economy. And I don't know, it's a tough question to answer.
Camshaft failures are one of the biggest complaints. There's a lot of mythology about the timing set as well. There's a whole bunch of people that carry on about how it breaks timing chains.
Really? I know they didn't have any problems when I was there that I can remember about timing chain issues.
Yeah, I'm not sure that it's really a thing, but it's a myth that everybody talks about how 4-liters break timing chains. One of the big questions, and maybe a big kudo, I guess, is how do I have a 4-liter that's run 300,000 miles and just purred like a kitten, and all I ever do is change the oil in the thing? Why does this engine last so long?
They do last a long time. 250,000 miles is pretty normal. And yeah, as long as you keep changing the oil, and that was one of the big selling points of the engine, was that it was durable and it lasts.
That leads into the next question, which is, what kind of oil should I be running in my stock 4-liter?
We just, at work, we were just running like 10W30 or 10W40, just regular dinosaur oil, no synthetic or anything.
Dinosaur oil, huh?
Yeah.
What about in the race cars you built?
We switched over to Mobil 1. It was 5-weight synthetic. We ended up, we started with the dinosaur oil and we went to a Mobil 1 oil. And then we switched from that to the Royal Purple oil. It was 0-weight. You have to have tight bearing clearances if you're going to run 0-weight oil. This engine ran at like 8,800 RPM. When we switched to the Redline oil, we picked up like 4 or 5 hundredths of a second.
Wow.
But we had tight clearances. We were running like 22 to, not quite 25, like 22 to 24 on clearance. 0.00 22, 0.00 24. Both bearings on the rods and mains. And we were running like 66. You know, if the air was like really, really good, we go at 63. We made an intake manifold change at Indy in 95, and we got to the final round. Then we made another intake manifold that was a 1/4 inch shorter on the runner line. Everything was the same internally. I mean, the port taper and all that stuff was the same, plenum volume same and everything. But we just shortened it up a 1/4 inch, and that was the engine that we did 860. That thing was singing.
Sounds like it. That's good information about the oil. Well, let's shift gears and talk a little bit about casting. You have some really good stories about casting. So let's start with the cylinder blocks. Why are the castings so dirty? So let me explain this a little bit. You see a fresh new casting on an AMC. When I used to be machinist, I see this all the time. I can see them where still sand that was embedded in the casting, and there are patches of this stuff. Yeah. We'd have to go through and knock it off.
Yeah, that came right from the foundry. With the head castings, I used to go to the New Haven foundry. It's like 20 minutes north of me. It was a minority-owned casting facility.
Without outsourced.
Yeah, the castings were, we had an outside vendor making castings. And it was, and I had no problem with the castings. A lot of it had to do with cooling and shrinkage and typical kind of stuff for the long cylinder head, a 6-cylinder head. They had to make up special tooling to try to knock all the sand out of there. Well, they had to do the same kind of thing with the blocks. So, they have, guys at the foundry making these blocks, and they're the hot ingots come flying out of, eventually get there, and they kind of cool down a little bit, but they're still red. And these guys are in fire suits knocking sand out of there with air guns, air hammering it, and, some got chisels, some got air hammers, and they're knocking the sand out, and it's on shaker tables, and it's one of those jobs that you wouldn't want to do. I went to the foundry once for the blocks. There was always a cloud in the air.
Let me ask you, we had talked about this.
Sorry, I didn't mean to get carried away.
So I understand why the castings are so dirty.
Well, they're on assembly lines, and these guys got to get these things in and out of there.
So we were talking about core shift. And,
oh, yeah, in the cylinder. The wintertime in Michigan, it gets pretty cold. It's minus 20, and these heads would come out and they'd be red hot. And they'd be going down, and these guys would be cleaning out the sand and getting all the sand out of it as best they could. And they would go out a flapper door on a conveyor, and then they would stack them on metal pallets
outside in minus 10.
Yeah, they were still red, yeah. But the ends, you could see the ends were starting to turn dark, and that's where the shrinkage would come in on the ends, the two end cylinders. And we tried to compensate for that. It was inadvertent that I noticed it when I was at the foundry one time. It was winter time, and I was there to rub some sand cores, and I was walking by where the heads were coming out and being stacked. Two guys out there stacking these heads, and they had a whole pile of these heads out there, and they were still glowing. You could feel the heat going by, and it was fenced off. And I was walking by there, and I could feel the heat coming from there. Now I see why the things are shrinking. Bob's like, what's wrong? I said, well, see the middle of the head? It's still glowing red. He said, yeah, they all do that. Summertime's not as bad, but wintertime, they cool off on the ends quick. I said, yeah, but that's where the shrinkage is coming from, the ends. I said, that's why. He said, it's getting cold faster, so, the middle of the heads are like the last to cool off.
If you got a block that was cast in the wintertime, you probably end up with more core shift, huh?
Probably.
So is that why, one of the questions is why is cooling so even? It's uneven. It seems like, you got core shift, you've got thin parts of cylinder walls and thin parts of heads and things that have been moved around.
Yeah, they have a spec, and then their spec is like plus or minus 30, which could add up to 60.
Oh, from end to end.
Yeah, and the other machining is plus or minus 15, which could add up to 30. So you got 60 and 30 at the wrong time.
So you could end up with a 90.
Yeah, well, yeah, everything could be really shifted quite a bit,
I think that's why you told me that 1 out of 4 liters is probably good for racing and the rest of them aren't.
That's right. We just got lucky on the one we had. We boarded 60 over and built the thing, and it seemed to work okay, and we'd have a gasket. Well, the only thing with the gasket, we had to go to a graphite head gasket. Graphite. Didn't I tell you?
Yeah.
No, the graphite gasket wasn't introduced on production. It was like for like a high-performance 4-liter. So you cut the cylinder head, the deck, to raise the compression. If you cut it in like 60 thou, the stock head gasket won't work. And even a Felpro competition gasket may not like it because of that heating problem between 5 and 6. The only alternative is to use a graphite.
See them a lot on iron block aluminum head motors.
Yes, because the aluminum moves more than the iron, so it has to, that little bit of give that it has to move back and forth allows it to stay sealed. So we put graphite on the 4-liter drag head, and it held up. The casting in the deck is only like 3/10 thick, and I cut off over 100 thousandths off that deck. And I said, we're not going to be able to use a stock gasket anymore.
So what's safe to take off of it then?
I think it was 115 thou I took off the head deck.
You took 115 thousandths off the head? Wow.
Yep. Yeah, you can't use the stock gas, and I told them that right off the get-go. You can't use the stock gas, and they tried it and blew it, and then I said, that's why I brought you all these graphites. I said, put the graphite gasket on there. It's fine, because it allows the head to move a little bit instead of just like grabbing the gasket and pulling it.
So did they work?
Oh, yeah, they're fine. Yeah, you put the we got, if we could get the gasket not to tear when we took it off, we'd put it back on. But generally, they tear. If they tear, then you got to replace it. But if you put something a little slippery on the deck surface, silicone or something slippery, and then we bolt the head down on it, and then
you can reuse it.
Yeah, at least get another 20 runs or so out of it or whatever until we took it apart. We took it apart a lot at the beginning. we're trying to make a race engine out of a production engine. I said, these things weren't made to go this high RPM.
That's a good segue to the next set of questions, which is sort of more about the cylinder heads.
Okay.
The first one is, why do they crack so much? Which one's cracked top of the head?
They're cracking at the top of the head?
Yeah, like the 0331s are really known for cracking.
That number doesn't sound familiar. That sounds like a newer head. Because they went to a different vendor. They went to a Tuppy, T-U-P-Y, Tuppy head. They think they started with the Tuppy around 2000, didn't they? Because I knew that New Haven was closing, so they couldn't get the New Haven heads anymore.
3-1s were 2000 to 2006.
I only had, 2000, so from 2000 to 2001, that's like a year, and I don't remember too much about that.
The entire engine is really thin. One of the reasons it was such a cheap engine to make is because they thinned it out so much, trying to get as much weight out as possible for fuel economy, right?
Yeah.
So I think we had talked about this a bit more, and the top of the head itself is pretty thin, so you end up with problems with the rocker pedals flexing and...
Yeah, when Tuppy got a hold of the head, they may have lightened it more. Because, the casting itself is only about 160 to 180,000 thick. It's not very thick up in that range, up in that area. I've cut them a couple apart before, and it seems to me that New Haven was a little more liberal with the material, have more iron up there.
You had said there are a couple of heads that are really good for flow. So I'm really curious, first off, what the heads are, why the other heads were built that weren't that good for flow.
Well, that was too many cooks.
Too many cooks?
To make a pie. I'm not the final word. A lot of times. Sometimes I am, but sometimes I'm not. And some of those heads, like the original head that I came up with was, the low port head was 86, 87, 88, 89, 90. The exhaust port floor came around the corner like a tongue. I used to call it the tongue port. That port makes more power than just a D-shaped port. It has to do with turbulence. In fact, have you ever heard of Sonny Leonard race engines?
Oh, yeah.
Okay, Sonny Leonard saw a Jeep head one time, and he looked at that. He said, why do they do that? So he incorporated that on one of his monster motors. I don't remember how big it was, but it was big. I don't know if it was like 900 cubic inches, but it was big.
Right.
And he put this port like that. He said, you didn't really notice much on the flow bench or anything, but when they ran it on the dyno, 40 horse.
Really?
Yeah. He said, I don't know what guy came up with this idea. It actually adds horsepower. I saw him on a old TV show when he was talking about, you saw this head? It had this like shape on the exhaust on the floor. He said, we did it on a race engine. And he said it picked up power. And he said it was substantial. The flow was the same, but it picked up power. He says, don't ask me how it works or why, it just does.
Your design?
Mine and one of the other engineers, he was the one that gave me the idea, because I went to the foundry rub cores and do all this stuff, and so I said, here, let's try this. Put that head on there, it picked up power.
Wow.
And they were like, did it flow more? I said, no, it flowed the same. It just got rid of some turbulence. That's all it did. For some reason, it had an effect on it. We're not really sure. I even talked to one of the PhDs, Tom Azimuth. I said, Tom, you got any ideas of why this thing works like this? And he goes, not really. He said, as long as it works.
This is a really interesting point. A lot of it's about trial and error, and you kind of glossed over something that I really like you to talk about a little bit. So when you're doing this testing, when you go to the foundry and you start rubbing castings, maybe you can explain what that means, what you're actually doing.
Oh, okay. The heads are they're poured around sand cores. It's compressed sand that's glued together with a special glue that break apart and come apart real easy after you've poured your hot iron or hot aluminum in it. And it's a box, and it's got holes for venting, and it's got holes for pouring.
Yank some cores off and start modifying them?
I just took my grinders. I had two big Dumor electric grinders. Had a whole box full of different types of stone cutters, and they were all different shapes, like round and D-shaped and cones and trees, and I would shape them before I even went to the foundry. I'd shape them to, I'd have a cylinder head, or I'd have a model, and I would be putting these stones around the model here, and I'd say, okay, that fits that. I'll use it for this, and then I would make another one, and I would grind these stones on a bench grinder. Just profile into whatever shape that I was looking for to do the job, so that when I got to the foundry, I could knock out a lot of castings using stones on sand. So I went to the foundry.
I want to make sure that guys understand this. So what you're really doing is you're going in there and you're taking the sand core itself, just sort of the negative space inside the head after the metal's been poured, and you are profiling. You are redesigning the head by hand before it actually gets any metal poured in there.
Yeah.
That's about the coolest job ever.
No, it isn't. It sounds cool, but it isn't.
So then you get to sneak these things through the foundry, and you've got your own special set of heads on the other end. Huh?
Yeah, well, I made one. I told you about that one. I made one of those into a race head. That four-cylinder, 246-liter head. If any of your listeners know of Mike Randall from Mesa, Arizona, him and his dad owned a dealership. It was a Jeep dealership. If anybody knows Mike Randall, he can tell you about that 246 engine that he bought that I had.
No, we'll see if we can find somebody that knows him, and we'll see if we can track him down. But
I think he's younger than me. If he's still around, I'd sure like to talk to him. It's been a long time since I talked to him.
In the next episode, Rick will address more common issues with the 4.0, and we may start talking about performance.